Okay, so this is a key to 15.2 Part B, and on this worksheet, you're looking at simplifying radicals, and these radicals are all square roots. Now, keep in mind that when simplifying square roots, you need to know what your perfect squares are. Okay, so you simplify square roots using perfect squares. So remember your perfect squares, the smallest perfect square is 1 because 1 times 1 is 1. The next one is 4 because 2 times 2 is 4. In fact, if you think about it, the square root of 1 is what? 1, right? The square root of 4 is what? 2. Okay, because 2 times 2 is 4, right? So the next perfect square is 9 because 3 times 3 is what? 9. So that means the square root of 9 is 3 because 3 times 3 is 9. Then the next one is 16 and so forth. 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and then 10 times 10 is 100, 11 times 11 is 121, and so on. So there are an infinite number of those. Okay? Now, for our problems, though, we're not going to get way beyond that situation here. So probably the largest you'll need is 121. Okay, now here's the idea. So in number 1, you have 4 times the square root of 36. Okay, now just like the previous worksheet, remember the previous worksheet, you had to simplify the square root of 28, and we saw how to do that. Okay, so you can use the largest perfect square that goes into 28, and you're going to rewrite all this until you get the simplest possible. Same thing here, except you just have 4 times the square root of 36. So we have this 4 right here. Remember, that means 4 times the square root of 36. And then the square root of 36, well, we just talked about that. Isn't 36 a perfect square? So what does that mean? Well, that means that the square root of 36 has to equal what? 6, because 6 times 6 is 36. Okay? So that becomes 4 times what? 6, which is equal to 24. So there's your answer. Okay? All right, let's go to number 3. All right, now remember when we did this, we always said make things easy on yourself. Use the largest perfect square. Because if you don't, remember what happened. If you don't, you're going to have to go through all these steps. And then sometimes you are not very careful and you mess up along the way. So it's always easiest to use the largest perfect square. Okay? Now, you have access to calculator, so use your calculator to help you. So let's look at 20. Okay, so one goes into all numbers, all whole numbers, right? So one's a factor of everything. Let's look at the square root of 20. So I have 3. So remember, this means 3 times whatever this simplified becomes. So 3 times the square root of 20. Is there a perfect square that goes into 20? And find the largest if you can. All right, well, we know 4 does, right? So what I would do is this. I would say, all right, so let's look at that. So that's going to be 20 divided by 4 equals, now look at what you have left. You have a 5. Well, is there a perfect square other than 1 that goes into 5? No. All right, none. So 4 is going to be the largest perfect square. So then you're going to say, all right, well, that's going to be the square root of 4 times 5, right? 4 times 5 is 20. And then I'm going to rewrite this as 3 times the square root of 4 times the square root of 5. All right, so I'm going to need a little bit of room here. Now, nowhere in here did it say show work, but basically you have to do something like this, right? So that'll be 3 times, I'm going to go ahead and rewrite this. Okay, so that'll be 3 times, now in 4 perfect square, so what does that mean about the square root of 4? Well, that means the square root of 4 is 2. So far I have this. I have 3 times 2 times the square root of 5. And can I simplify the square root of 5? No. So the answer is 3 times 2 is 6. I get 6 square root of 5. 6 times the square root of 5. Okay? All right, number 3, I'm going to go ahead and do the rest on paper because there's not going to be enough room to do these. All right, number 3. Number 3, I have negative 7 times the square root of 24. All right? Okay, so here's what I would do. I would say negative 7 times, all right, let's think about the radicand 24. Is there a largest perfect square that goes into 24? besides 1? Well, let's try 4. I know 4 goes into 24, so let's see what happens when I divide 24 by 4. 24 divided by 4 equals, hey, that's 6, right? Besides 1, is there another perfect square that goes into 6? Nope. So you're done. At least you're done at this point. So that's the square root of 4. 4, look, 4 times 6 is 24, right? So we've square root of 4 times 6. And then rewrite this as -7 times the square root of 4 times the square root of 6. And then you can simplify the square root of 4, because what's the square root of 4? Well, the square root of 4 is 2. So I get -7 times 2 times the square root of 6. And then that becomes -7 times 2 is -14, square root of 6. Okay? That's number 3. So number 3 is -14, square root of 6. All right. Number 4 is square root of 27. All right, so let's think about this. Besides 1, what's another perfect square that goes into 27? All right, well, that one's easy, right? So you'd say 9. And then look, 27 divided by 9 is 3. Is there a perfect square that goes into 3 besides 1? No. So 9 times 3 is 27. So it becomes the square root of 9 times 3. Then rewrite this as the square root of 9 times the square root of 3. And remember, 9 is a perfect square, so that means the square root of 9 is 3. So you get 3 square root of 3. Okay? And you can't simplify the square root of 3 any further, because the only perfect square that goes into the radicand 3 is 1. So you're done. So the answer number 4 is 3 square root of 3. All right? Okay, number 5. Okay, number 5, you have the square root of 40. Okay, square root of 40. All right, and then that one's not that bad either, because you're going to say, oh, I know right away that 4 goes into 40. Sure does. So let's see what happens. 40 divided by 4 is 10, right? Now, think about 10. Is there a perfect square other than one that goes into 10 evenly? No. Remember, you might say 4. No, because 4 times no whole number is 10. 4 times 2 is 8. 4 times 3 is 12, right? So there's no perfect square other than one that goes into 10. So 4 times 10 is 40. So that'll be square root of 4 times 10, just like this. And so that becomes the square root of 4 times the square root of 10. And then the square root of 4 is 2, so you get 2 square root of 10. Okay, so the answer number 5 is 2 square root of 10. So 2 square root of 10. Okay, number 6, you're taking the square root of a fraction. Okay, no big deal. I can handle that. So number 6, you have the square root of 24 divided by 25. Okay, so we know that I can rewrite this as the square root of the numerator divided by the square root of the denominator. Okay, now let's look at the denominator for right now. The square root of 25. Well, 25 is already a perfect square in it. So what's the square root of 25? Yep, it's 5. So all I got to do is figure out how to deal with the square root of 24. So let's think about the square root of 24. Okay, so here's what you do. So again, ask yourself, which of these perfect squares besides 1 will go into 24 evenly? All right, well, 4, right? Because look, 24 divided by 4 is 6. Besides 1, no other perfect square goes into 6 evenly, so 4 times 6 is 24. So it becomes the square root of 4 times 6, right? Okay, and so that's going to equal the square root of 4 times the square root of 6, all divided by 5. And then I know that the square root of 4 is 2, so the answer is 2 square root of 6 divided by 5. All right, that's number 6, 2 square root of 6 divided by 5. All right, number 7. Okay, number 7, same thing. You're taking the square root of a fraction. That's 100 divided by 121. And then I can write this as the square root of 100 divided by the square root of the denominator, right? And notice both of those are perfect squares. What's the square root of 100? 10, because 10 times 10 is 100. What's the square root of 121? 11, because 11 times 11 is 121. So you're done. There's your answer. So number 7 is 10 divided by 11. Okay? All right, number 8. Okay, number 8, you have this. You have the square root of 13 divided by 81. Okay? All right, well, I can write this as the square root of 13 divided by the square root of 81, okay? And let's look at 81. Y'all agree that 81 is a perfect square? So what's the square root of 81? Okay, 9. All right. Now let's look at 13. Besides 1, is there any other perfect square that will go to 13 evenly? No. So you're done. There's your answer. The square root of 13 divided by 9. That's it. Okay. So that's answer number 8. Square root of 13 divided by 9. Okay, let's look at number 9. Number 9, you have the square root of 60 divided by 25. Okay. All right, so I can rewrite this as the square root of 60 divided by the square root of 25. And then the square root of 25 is just 5, so that goes in the denominator. But let's talk about the square root of 60. Is there a perfect square that goes into 60? All right, besides 1. All right, let's try 4. 60 divided by 4 is 15. All right, so 4 goes into 60. Now, ask yourself about this 15. Is there a perfect square besides one that goes into 15? No. So you're done. So you're going to say that's going to be the square root of 4 times 15, right? Okay. And then I would rewrite this as the square root of 4 times the square root of 15 divided by 5. And then simplify as much as you can. So don't stop there. Remember, you know what the square root of 4 is. Don't leave it at the square root of 4. You know the square root of 4 is 2. So you got to say 2 square root of 15 over 5. And then you're done. Now, you're done at this point. Okay, now here's what some people make a mistake. Okay, so this is mistakes. I need to remind you about this so you don't do this. All right, so what they'll do is they'll say, oh, I know that 5 can go into 15. So they'll do this. They'll say 1 and 3, right? And then they'll say that's going to be 2 square root of 3. Well, that's not true. That is not true because that is not 15. You see, if you had 2 times 15 over 5, then you could. This is correct. 2 times 15 divided by 5 is not 2 times the square root of 15 divided by 5 because look, what's the square root of 15? Is it 5? What's what I'm doing? Square root of 15, square root 15, is that 5? It's not 5. It's 3.8729 and so on, right? Okay? Now, if you had that, then you could say, then you could reduce like this and say 2 times 3 is 6. That's true. This is not, so don't make that mistake. So all this to tell you, this is your answer. Don't do anything else. That's your answer. Okay? All right, so that's number 9. So I get 2 square root of 15 divided by 5. Okay, now number 10. So in number 10, you have the square root of 68 divided by 361. Okay? Square root of 68 divided by 361. Okay, so I'm going to write it like I've been doing. So I know that's going to be the square root of 68 divided by the square root of 361. And then you may recall what I just said. Well, you said we wouldn't have to worry about anything further than that. Yeah, well, sometimes things are thrown in. But let's look at the square root of 361. What I would do is first of all, is 361 a perfect square? You don't see it here. Remember, there's an infinite number of perfect squares. I only stopped here. Remember, the next one is 144, right? Because 12 times 12 is 144. And the next one will be 169, because 13 times 13 is 169, and so on. But what about 361? Is 361 a perfect square? Well, how would you think about this? If I put the square root of 25 in the calculator, what do we get? Square root of 25, we got 5. So yes, 25 is a perfect square because I got a whole number. Is 81 a perfect square? Yes, it is, because when I use the calculator, what's the square root of 81? Square root of 81 is 9. 9's a whole number. 9 times 9 is 81. So 81 is a perfect square because I ended up with a whole number there. So let's do 361. Square root of 361. Let's see what happens. There you go. Square root of 361 is 19. So that means at some point 361 would be in here. So this becomes, in the denominator, that's going to be a 19. That's all that's going to be. Now let's go to the square root of 68. All right, so let's look at 68. So besides 1, let's try and see if 4 goes into 68. 68 divided by 68 divided by 4. There we go, 17. And is there a perfect square other than one goes into 17? No. So you're going to say 4 times 17, 68. So this would be square root of 4 times 17. And then rewriting this, that's going to be the square root of 4 times 17, square root of 17 over 19. And the square root of 4 we know is 2, so you do have to go further. So the answer is 2 square root of 17 divided by 19. Okay? So that's number 10. So number 10 is 2 square root of 17 divided by 19. And that's it. So it's not that bad. Just use your knowledge about perfect squares, use your knowledge about how to simplify radicals, and use your calculator to help you. And that is all this is. So that's the key to section 15.2, part B.